Here's a typical motor control center diagram showing a circuit breaker combination starter, start-stop push button, control transformer, and run pilot light. With the stop button closed, the start button open, the M contacts are in the open position. When the start button is depressed, the contacts close and power flows through the coil, illuminating the pilot light, then through the normally closed overload contact, closing the M contacts. When the start button is released, power is maintained to the coil through the auxiliary contact M. When the stop button is pressed, the power drops out to the circuit and the M contacts open. Even when the stop contacts return to its normally closed state, power cannot flow until the start button contacts close. Let's examine how a motor control center is composed. The incoming section is where the distribution power is connected. It can be a main circuit breaker shown here, or main lugs only as seen in this photo. From there, the power gets distributed by an internal bus system. This arrow points to the ground bus. Further examining the bus system, you will see the main horizontal bus, which is sized depending on the load connected to the motor control center. The power is then distributed to each section by the vertical bus. The bus is housed in an enclosure that's available on different environmental ratings as designated by NEMA and IEC. We will go over these in more detail later. Control and power wire is distributed through the vertical, top, and bottom wireways. The units, also known as buckets, contain motor starters or feeder switches or breakers. Other distribution equipment such as transformers or panel boards can also be contained in the motor control center. Accessories and modifications such as push buttons, selector switches, and indicating lights may be added to tailor the units for specific applications. Here are the enclosure ratings for both NEMA and IEC, along with their descriptions. It is important to note that these designations can vary by different manufacturers. There are 4 enclosures that carry the same description, however the NEMA rating and the IP rating are different. The description is general purpose with or without gasketed doors. The NEMA 1 vented is equivalent to the IP20. The NEMA 1 filtered is equivalent to the IP30. There's a NEMA 1 non-vented, which is equivalent to the IP40. And lastly, a NEMA 1 with a drip hood, which is equivalent to an IP41. Again, all these carry the same description, general purpose with or without gasketed doors. Now, what is a motor control center bucket? Basically, it is a distribution point of the MCC. It could be used to control a motor and could be a motor starter. Many manufacturers offer different sizes or compact or dual-mounted starters. It can also be an adjustable frequency drive. The bucket can also be a feeder for some other equipment such as lighting. The feeder can come in the form of a fuse switch or a circuit breaker. It should be noted that in the smaller current sizes, greater density can be attained by dual mounting these devices in the same bucket. Now it's time to take a closer examination at the components that make up a bucket. First, there's the disconnect switch. This could be either a circuit breaker or a fuse disconnect switch. The mechanical unit latch serves as an interlock mechanism, preventing the door from opening when the circuit breaker is in the closed position. There's the operating mechanism, which turns the breaker on and off and also goes into the trip position when the breaker trips. There's the motor starter itself. There's the pilot devices such as the start-stop push button, selector switch, and indicating lights. Terminal blocks are usually mounted on the side of the bucket. Now, why do customers purchase motor control center buckets? One simple reason is that the old unit failed and needs to be replaced. Another could be that renovations or additions may be required in the plant, presenting the need for an additional starter or feeder. Oftentimes, smaller motors are replaced by larger motors, making it necessary to change a starter in the motor control center. Many companies are now seeking to recoup some energy costs and are switching to adjustable frequency drives and retrofitting their motor control centers. Purchasing considerations include available factory space. Next, we'll spend some time going over NEMA wiring class designations. Type A indicates that the starter units are supplied without any wiring to terminal blocks. Type B stipulates that the wiring is connected to terminal blocks within the starter unit. And Type C refers to units that are wired to master terminal blocks mounted in either the top or bottom of each vertical section. Class designations precede the type classification. Class 1 signifies that there is no interconnection wiring between the units. And Class 2 provides complete control system with interconnections between the units. These units can be next to one another or in totally different vertical sections. Now we'll take a look at the selection factors for motor control center units that are starters. We need to know whether it's going to be a full voltage non-reversing or a full voltage reversing, if it's going to be a 2-speed, and if it's going to be a 2-speed 1-winding or 2-speed 2-winding, if a soft start is required, and what type of disconnect does the customer want ahead of this starter. Does he want a circuit breaker, motor circuit protector, or fusible switch? Once the type disconnect is established, it's necessary to know the size of the trip or fuse clip that is required. We need to know the horsepower or the NEMA size, the motor voltage,